Hello everyone, welcome back to my channel. So in the series of this X-ray production, we have already discussed in the previous video that what the atomic structure looks like and also the history of X-rays, how the X-rays are produced. We are going to discuss in this section, and earlier we have already discussed the basic idea behind X-rays. Okay, so in this particular video we are going to discuss Brehmsstralung scattering, some basic terms related to atomic structure and characteristic X-rays. Okay, so by the end of this video you'll have a clear picture in your mind that how X-rays are formed and what is the basic principle behind X-ray production. So before starting the video, if you haven't subscribed the channel, then please subscribe the channel and don't forget to press the bell icon. So let's get started. So the atomic structure, let us suppose this is an atomic structure with 7 protons, 7 neutrons and 7 electrons. So the protons and the neutrons resides in the nucleus. They are present inside the nucleus, and the electrons are revolving around the nucleus in the circular orbit, as you can see in this particular atomic structure. Okay, now let us discuss some basic terms which are related to atomic structure, which are used to describe a particular atom. So first term is atomic number, which is denoted by Z. Now what does it mean by atomic structure? Atomic number. So the atomic number is actually the number of protons present in a particular nucleus. Okay, or we can say, since the number of protons is equal to the number of electron in a neutral atom, so the number of electrons present in a neutral atom. So the atomic number of hydrogen means the Z of hydrogen is 1, for helium it is 2, and for carbon it is 6, and so on and so forth. Now let us discuss what is mass number. Mass number is denoted by A. As we all know that the mass of the entire nucleus resides, the mass of the entire atom resides inside the nucleus, right? And what are the particles which are present inside the nucleus? The particles are protons and neutrons. So what does mass number mean? Mass number is actually the number of the total number of protons and the total number of neutrons present inside the atom. Okay, so number of protons plus number of neutrons makes up the mass number. So the mass number of hydrogen is 1, helium it is 4, for carbon it is 12. Now let us discuss what is nuclide. Nuclide is a particular variety of atom which is characterized by their respective A and Z. Okay, means a particular atom which has a particular A and Z is called a nuclei. For example, hydrogen. For hydrogen, A and Z both are 1. For helium, A and Z are respectively 4 and 2. Similarly, for carbon, it is 6 and 12, and so on and so forth. So nuclide, for every nuclide there is a different A and Z, different mass number and different atomic number. Now let us discuss what are isotopes. Isotope is a nuclide which have same proton number, P for proton number and P for isotope. This is how you can memorize what does isotope mean. So isotope is a nuclide which have same number of protons but different number of neutrons, or you can say that same atomic number but different mass number. Now what are isobar? Isobar is a nuclide which has same mass number but different atomic number. So these are the basic terms which are related to the atomic structure, which you should know in order to describe a particular atom. Now our next topic is binding energy. Now what is binding energy? Binding energy is the energy which is required to remove a particular atom from its orbit. Okay, so as you can see in this diagram, the outer shell electron, it is very easy for us to remove the outer shell electron rather than the inner shell electron. Why? Because energy required, or the binding energy required for this particular outer shell electron is very less than the inner shell electron. Okay, now what is the reason behind it? Since we can see in this diagram, let us suppose there are many orbits in a particular atom. Here there is only 2 orbits, but let us suppose there is an atom which has many orbits and many electrons. So what will happen to that atom is the inner shell electron will be shielded by the outer shell electron. So in order to remove the electron which is in the inner shell, the energy required is very high because it is shielded by the outer shell electron. Okay, so the binding energy of the inner shell electron is always more than the binding energy of the outer shell electron. Or we can say that the energy required for removing the outer shell electron is very less than the energy required to remove the inner shell electron. Okay, so the concept of binding energy is now clear for all of us. Now the main topic comes, which is types of X-ray production. How X-rays are produced and what are the different processes from which X-rays can be produced. So there are mainly 2 different processes from which X-rays are produced, which is the X-rays produced due to Brehmsstralung scattering, and the next is characteristic X-rays. Okay, and the majority in the majority cases, the X-rays which are used in diagnostic radiology are Brehmsstralung X-rays. Okay, now let us discuss what are Brehmsstralung radiation and what is the main process behind it, how these rays are produced. Okay, now let us understand it with this diagram. What happens is a high speed electron from filament enters the atom. So this is how a high speed electron enters an atom. Okay, now it is nearer to the nucleus, and nucleus is what? Nucleus is positively charged, and electron is what? It is negatively charged. So there is some Coulomb interaction between both of them. So because of Coulomb interaction, what will happen? This nucleus will try to attract this atom towards itself. Okay, so due to which what happened? This electron gets deviated from its path and it is slowed down. So this accelerated electron is slowed down due to this due to the attraction of the nucleus, due to Coulomb interaction between the nucleus and the electron. Now since it is now deaccelerated, okay, this atom is now deaccelerated. Due to the deacceleration of this electron, there is a loss of energy of this electron. Okay, now this loss of energy will be released in the form of a photon, and this released photon is due to the Brehmsstralung scattering. Now what is Brehmsstralung scattering here? This entire process, the electron which is scattered due to this nucleus, this is called Brehmsstralung scattering. Okay, now this photon which is released due to the deacceleration of this electron is called Brehmsstralung X-rays. Okay, so this is how Brehmsstralung X-rays are produced. Okay, it is mainly due to the Coulomb attraction. So when this Brehmsstralung scattering occurs, it occurs when the accelerated electron is interacted with the nucleus. Okay, and there is a Coulomb interaction between the nucleus and the electron. So now let us discuss it point by point. This Brehmsstralung radiations are also called breaking radiation or general radiations. Okay, Brehmsstralung radiation are generated when an accelerated electron passes nearer to the nucleus. Okay, so here we can see that this accelerated electron, when passes nearer to the nucleus, it is deaccelerated, and this is how Brehmsstralung X-rays are formed. Electrons have negative charge, nucleus of the atom have positive charge, and due to which there is an electromagnetic force between the both incoming electron and the nucleus. Okay, so due to this electromotive force or the force of attraction between the nucleus and the electron is deaccelerated. Okay, and due to this deacceleration, the direction of the electron is changed, and also due to this deacceleration of the electron, it loses some energy, and this loss of energy is converted into the energy of the X-ray photon. So this is the basic physics behind this Brehmsstralung X-ray production. Okay, now the amount of energy lost by the incoming electron depends upon two factors. Okay, now what are the two factors? How nearer they pass through the nucleus, means the incident electron is how much nearer to the nucleus, how much nucleus can attract the particular incoming electron. And second factor is the energy of the incoming electron. So how much energy the incoming electron possesses, it's another factor, and another factor is how much the particular incoming electron is nearer to the particular nucleus. Okay, so these are the two factors which on which the amount of the energy loss depends. Okay, now there can be some other effect. What is it? When is the Brehmsstralung X-rays produced with maximum energy? So when does this happen that maximum energy of photon is produced? It is when the electron directly strikes the nucleus of a particular atom. Okay, so when electron directly strikes the nucleus of a particular atom, what happens is the exact energy of the photon, X-ray photon, is released, which is equal to the energy of the incident photon. Okay, so this is how the X-ray photon is produced with maximum energy. Maximum energy means what? Energy which is same as the energy of the striking electron. Now let us discuss what are characteristic radiation. So firstly we are going to understand it with the help of this diagram. So this is nucleus. Okay, there are here there are neutrons and protons, and this pink shell, pink circles are actually electrons. Okay, so electrons are denoted by this pink circle, and this red dotted line is orbit of the particular electron. Okay, now this is an accelerated electron. So let us see what happens. This accelerated electron strikes a inner shell electron, means K shell electron. Now this K shell electron gets excited because this accelerated electron gives energy to the inner shell electron, and this inner shell electron is ejected out from this shell. Okay, because it has gained some energy. Now what happens is some instability has created, a hole has created. Okay, so what will happen? An outer shell electron will try to fill this vacancy. Okay, so when this outer shell electron will try to fill this vacancy, there is a transition from higher level to lower level. Okay, and we have learnt it, we have already discussed it, that Bohr gave his statement that whenever there is a transition from between two different levels, a respective photon is released. So this is how a photon is released, which is called characteristic X-ray radiations or characteristic radiations. Okay, so this is the basic physics behind the behind the production of characteristic radiation. Okay, so whenever there is an accelerated electron which strikes the inner shell electron, and this inner shell electron is knocked out from its shell, and an outer shell electron tries to fill this vacancy, there is instability is created over here, then the photon which is emitted out as a result of this transition is the characteristic radiations. Okay, now when an accelerated electron having little more or equal binding energy than the orbital electron, it ejects an electron from its orbit, and the atom become ion and unstable. Okay, now the unstable atom try to become stable as soon as possible. So to stable the atom, generally an electron from outer shell move to the inner shell, and there is a transition between higher shell to lower shell, and a photon is released. Okay, and this photon is X-ray photon. Now the energy of this X-ray photon depends upon the characteristic of target material which we are using. Okay, so how much energy the orbital electron possesses depends upon the property of the target material. So this is how the energy of the X-ray photon also depends upon the characteristic or the property of the target material. Now the binding energy of different shells is different. Okay, so the material is same, tungsten. So the binding energy of K shell is 69.5 kilo electron volt. The binding energy of L shell is 11 kilo electron volt. So whenever there is a transition from K shell to L shell, a photon will be released in the form of X-rays. So what would be the energy of that particular photon? It would be equal to the difference of both the energy levels, which is equal to 58.5 kilo electron volt. So this is a rough idea behind what will be the energy of a particular photon. So this is how the energy of the X-ray photon would depend on particular material which we are using as a target material, because the binding energy of for different materials for different shells will be different. Now let us understand in detail how these characteristic X-rays are produced. Okay, so electron, yes, so this is how an electron strikes the inner shell electron, and both the electrons are emitted out. The incident electron and the electron which is revolving inside the inner shell is also knocked out from its shell. Okay, now L shell electron will try to fill this vacancy, and a photon is released in the form of X-rays. Okay, so this is the basic physics behind the characteristic X-ray production. So that's all for X-ray production. These are in this video we have in detail discussed the basic principles behind the X-ray production. I hope your all doubts related to X-ray production would have been resolved in this particular video. If you like the video, then please give it a thumbs up, and thank you so much for watching the video.